very important exercise to find the basis and dimension. So we need to find the basis and dimension of the solution space W of the system of linear equations. So these are the three equations given to us, and we need to find the basis and dimension of the solution space W. If I'm having all these three equations, then just writing the coefficient of x over here and the coefficient of y over here, and then z, then s, then t. So the coefficient of x is 1, 1, 2. The coefficient of y, 2, 2, 4. The coefficient of z, -4, -2, -2. The coefficient of s, 3, 2, 3. And the coefficient of t is -1, 1, and 4. And then we need to write the variables x, y, z, s, t, and then 0, 0, 0. Please mark this as 1. Let me name this to be your matrix A, and we need to reduce this matrix to a row echelon form, right? So this is our matrix A. I'm having leading entry 1 over here for the first row. To make this the leading element, I need to make these two entries to be 0. For that, let's multiply the first row with -1 and adding its elements to the row 2, and also we need to apply the operation multiplying the first row with -2 and adding its elements to the third row. So writing the first row as it is, and we are changing the row 2 and 3, and on applying the operations we are getting here, for the row 2 we get 0, 0, 2, -1, 2. And for the row 3 we get 0, 0, 6, -3 and 6. So this becomes the leading element for the first row. For the second row we are having the leading entry to be 2. To make this to be the leading element, I need to make -4 to be 0 and the entry 6 to be 0. To get 0 in place of 4, I need to multiply the row 2 with 2 and adding its elements to the row 1. To get 0 in place of 6, again I need to multiply the row 2 with -3 and adding its elements to the third row. Writing the second row as it is, and the first row is changed into 1, 2, 0, 1, 3. And the last row changes to 0, 0, 0, 0, 0. So we are getting the two non-zero rows over here, and this is your reduced echelon form matrix. So now replacing the matrix A with this reduced form, right? So the system 1 reduces to this. So from this we get the first equation to be 1 multiplied with x we get x, plus 2 multiplied with y we get 2y. Similarly we get the coefficient of z to be 0, and then plus s plus 3t equal to 0. And then the second equation, multiplying 0 with x we get 0, multiplying 0 with y we get 0, multiplying 2 with z we get 2z, and then minus s plus 2t equal to 0. So this implies x plus 2y plus s plus 3t equal to 0, and then 2z minus s plus 2t equal to 0. So these are the two equations. Okay, how many number of equations we are having? 2. And how many number of variables we are having? Yes, 5, right? Now this is your set of two homogeneous linear equations, right? And how many number of free variables we are getting? The formula is, we need to subtract the number of equations from the number of variables. Please mark this as 2. Since 2 is a system of two homogeneous linear equations in 5 variables, therefore you may learn this: the number of free variables is equal to the number of variables minus the number of equations. How many number of variables we are having? 5, minus, and the number of equations? 2. So the number of free variables are 3. Now how to select which variables to be the free variables? Always select those variables to be the free variables whose coefficient is not equal to 1. In these two equations, the variables whose coefficient is not equal to 1 are y z and t, right? So we need to choose these three variables to be the free variables, y, z and t, right? These are the system of homogeneous linear equations. We have chosen y, z, t to be the free variables, and now we need to get the values of x and s from these three variables, right? By giving them certain values. Now, how to give the values to these three variables? We need to give them some value, right? Just learn this format. Right here, 1, 0, 0 and then 0, 1, 0 and then 0, 0, 1. The identity matrix, right? Which means what values we are giving to the variables? We are giving the value 1 to y and the value 0 to z and the value 0 to t. So putting y equal to 1, z equal to 0 and t equal to 0 in these equations to get the values of x and s. So from the first equation we get x plus 2 plus s equal to 0. From the second equation we get minus s equal to 0. That means we are getting s equal to 0 and x is equal to negative 2. So for these values we are getting x equal to negative 2 and s equal to 0. And now putting y equal to 0, z equal to 1, t equal to 0, we get from the first equation x plus s equal to 0, and from the second equation we get 2 minus s equal to 0. So from these we get the value of s to be equal to 2 and the value of x equal to negative 2. Similarly, for y equal to 0, z equal to 0, t equal to 1, we are getting from the first equation x plus s plus 3 equal to 0, and from the second equation we get minus s plus 2 equal to 0. So from here we get s equal to 2 and x equal to minus 5. So therefore we are getting the basis to be okay. So from the first set we are having the value of x as minus 2, the value of y 1, then value of z, then value of s, then value of t. Then from the second set we get minus 2, 0, 1, 2, 0. From the third set we get minus 5, 0, 0, 2, 1. So these forms the basis for W. And what about the dimension of W? How many number of elements present in the basis? 3. So the dimension of W is 3. Alright, thank you.